Hi and welcome to this video about writing a simple debugger, but this time using the Microsoft Debugger engine. Compared to the previous video where we used the basic Windows debugging API, we need something more powerful in order to access things like symbols, set up breakpoints and such things that we're familiar with when working with debuggers. So in order for us not to have to write everything ourselves, we can use the Microsoft Debugger engine, which is the basis of the Microsoft famous debuggers like WinDebug. Okay, so what does that look like? The debugger engine provides some API. This is a COM-based API, which means we have a bunch of interfaces that we need to use in order to interact with the debugger engine. And so this is what that looks like in principle. We have an object that is referred to as the client object in the documentation for the debugger API, and this one implements a bunch of COM interfaces. You can see here the main ones that we're going to use. We're going to use only a subset of those. We're going to we'll use all of them, but we'll use some of those as needed. Each one, of course, has its own set of methods. And also, since the debugger engine has been around for many years, newer versions of these interfaces exist. So we have iDebug Client as the basic interface for iDebug Client, but there's also iDebug Client 2, iDebug Client 3. In fact, there's iDebug Client 9 even today, at least at the time of this recording, which provides more functionality. In many cases, we can get away with using the base interfaces, but sometimes we need a more recent version of interfaces. And that's not going to be a real issue here. The other thing to note is that it's also about communicating with the debugger in some way, such as we need to get some notifications. You might recall from the previous video, we use a Windows API function, like wait for debug event to get notification for the next thing that happens in the target process we're debugging. So in this case, this is going to be wrapped by the debugger engine and provided to us as a bunch of callbacks. And so we'll need to provide our own COM object that implements a bunch of interfaces. Usually 2 interfaces will suffice. One of them is output callbacks, which will provide us with the output of any commands we're going to tell the debugger to do, or things to tell the debugger to do. And we want to output that to the user that is interacting with the debugger. And so we want to build something which is like the console debugger, like CDB. And then iDebug event callbacks would allow us to get the actual events for things like DLL being loaded, thread being created, and things like that. Kind of similar to what we've seen in the previous video, but this time we have some extra stuff there and it's built in a certain way. So we'll have to do some COM implementation here, not just working with the client object by calling functions. And so if you think about the Microsoft provided debuggers like CDB, NTSD, KD, WinDebug, these are really just certain wrappers in one form or another over this API that uses this API to get all the functionality. And so this is what we want to do as well. And this is implemented using a DLL called dbgeng.dll. Okay, so let's begin. So I've added another project to the previous solution, just that we have these 2 things in the same solution for convenience. And I've just created a standard console application as I typically do. And so the way we're going to go about it, the first thing we have to do is to actually register for various interfaces and so on. So we actually have no choice but to implement a COM object. So I'm going to create a class here. I'm going to implement that from scratch. Let's call that just debugger. And this debugger is going to do 2 things. On the one hand, it's going to provide support for the callbacks. And the other thing it's going to do is hold on to the various interface pointers to communicate with the debug client. And so first we need to add some includes. Let's start with windows.h just in case. And then there's the debugger engine. And so the debugger engine is provided, the header is provided by the standard Windows SDK headers. We can definitely go with that. However, the actual DLL is provided with Windows, which is also fine, but we need some extra DLLs, like when dealing with symbols, for example, we need a DLL called simsrv.dll. And this DLL is not provided with Windows. It's provided as part of debugging tools for Windows. And so perhaps a better way, which would provide all the dependencies, is getting this information using NuGet. So I'm going to right click here the references and go to manage NuGet packages. And you want to search here for the debugger engine. Let's try dbg-eng, maybe that would be good enough. And you can see there's a Microsoft debugging platform dbg-eng, looks good. Let's use that one. So I'm going to install that. And this will give us an updated header if there is something that needs to be updated. But more than that, you can see there are a bunch of extra binaries have been added here for us for the various architectures, so you can technically compile that to all of the architectures Windows supports. You can see there's a few things here. It's not just dbg-eng, there's also dbg help, which is also normally provided by Windows, but that might be an updated version. We have the debugger model, things like that, that support the latest scripting capabilities and stuff like that. There's also msdia, which is the a helper DLL to deal with symbols. So we get these things, there will be copy to the target folder, so we'll have that like out of the box. You won't have to try to copy certain files from the debugger engine, hopefully, from the normal installation here. I do not see CMSRV here, which is a bit concerning, so we might still need to do some work by copying this file or just bringing it here and just adding that to the project. We might need to do that if we have to, and probably we will. Anyway, let's start by adding an include for my favorite smart pointers. For COM, let's use ATL here. So what we want is a bunch of smart pointers here. One of them is going to be debug client. That's kind of the fundamental interfaces. Let's call that M client. And technically, I could take something more recent, like version 3 or version 6 or whatever. These are still not that recent. I mean, they've been around for quite some years. So we can take something which has more functionality. We might not need it in practice, but we can take that as well. And then we have a few more things we might need, like iDebug control. Let's call that M control. Again, there are a couple of versions, a few versions of control. There's just not just the one, there's 2 and 3 and so on. And this, of course, is all documented. One way to get the documentation is just by searching online, obviously, but there's another way which I typically prefer. You can run WinDebug itself and then press F1. You'll get the debugger documentation, which is bundled with WinDebug. And in fact, the documentation for the debugger API is here. So I can do something like iDebug client to look for that. We can find the interface. We can see here all the functions this interface provides. We can also go with the locate button here to find where it's in the actual documentation tree. And you can see iDebug client 2 and 3 and 4 and so on. It's not fully updated to the latest and greatest because this offline documentation is not updated in the same cadence as the online documentation, but still it should be good enough for most purposes. And if something is missing, we can always go online to find the rest. So you can see here iDebug advanced and iDebug control and so on. So all these interfaces here are here. Of course, we can go to each one of them and get the description for methods and so on. Documentation is not perfect, it's not very detailed, but it's mostly good enough to get going, and sometimes it will require some extra experimentation to get some things working. Okay, so we have this control interface. We might need others and we'll add them as needed. And so what I want to do is to have a function here, let's call that simply init, whose purpose is going to be to initialize these interfaces, that is to create the debug client object and then query for the interfaces as needed. And so I'm going to implement that one already here just to see what that would look like. And so apparently there's some bug here, very weird, that brings us to the wrong location. So let's go ahead and try this again. So we have include to the debugger. Let's have hresult debugger init. So the purpose of init is to create the debugger client object as we've seen in the slide, and then get the first interface from it, could be anyone, and then grab the others by using query interface. And so to make it a bit easier to work in terms of error handling, we do something very, very simple, just to make it not at least obvious when there's an error. I'm going to have some HR macro here. And what HR is going to do, it's going to just call whatever we have here, whatever we have as that X here. And then if that failed, it's going to just return that H result. So I'm just having this little simple macro, so we can just quickly wrap any call with this HR macro. So for example, what we need to do here is call the function debug create. That's the function that you get from dbgeng.h, which is almost the only function you have there as a global function to get the object created, the client object created, and get the first interface from it. And so the first interface that I want is going to be iDebug client. I decide to go with something like version 6, and it doesn't really matter really, so let's go with 6. And then we need to get the result, which is going to land in mClient. And so if this doesn't work for whatever reason, we want to just bail out with this HR macro. It will just return that failed thing, whatever that may be. So let's just make sure we're not making any mess here by having a parenthesis just in case. So once we have that, let's get the first interface, the second interface really. So I'm going to take the client, sorry, let's use HR again. I'm going to client and query interface and get that to the control. So essentially I want to take the interface of iDebug control from that same object. So this is unlikely to actually fail, but let's just use this for consistency. And once we're done, we can just return SOK saying everything is fine. Let's just build this to make sure that nothing weird is happening here. So one thing that we're missing, of course, the compilation succeeds, but the linking fails because the debug create function is not anywhere that the linker is aware of. And so we could actually call debug create by dynamically linking to debug engine using load library and get proc address. That's definitely an option. But in this case, I'll just do things in an easier way and just add a linker option to add that as a library, dbgeng, and that should be good enough to make this code link successfully. And hopefully that will also work once we run it, but at least we have something to start with. So now we have the basic init, which will create the client object, but of course there are other things that we actually need. So first we have to implement interfaces on our own, and this is about these ideas that I mentioned earlier, which is the callback. So we have iDebug callbacks, and so we need to implement these interface event callbacks. And there are a couple of those interfaces. There's a wide version for Unicode, there's a 2 version that has some tweaks, but we'll stick with the simplest one. And then we're also going to need to implement the debug output. There's just no way around that. We need to get the output somehow. So just going to output callbacks. Again, you can see there are a bunch of versions, but we're going to use the basic one, which should be good enough. So once we have that, let's see if Visual Studio is nice enough to implement all these interfaces for us, just by giving us the basic thing of empty implementation. You can see here it does so. And so just going back to see what we have here, we have these functions being added here by the Visual Studio infrastructure. You can see there's quite a bit of functions here. And in fact, there's even, I think, a bunch of maybe errors here in terms of the comments. The comments are in error, but the actual functions are okay. So let's put them in the public location, even though it doesn't really matter, just for things to look nicer here. So we have std call here, which is also missing here. But again, not too important because we're building a 64-bit executable, which has just one calling convention. Doesn't really matter. Anyway, let's build that to make sure that the Visual Studio infrastructure didn't mess things up, and it didn't. Great, so now we have to implement all these things. Of course, not everything has to be implemented fully, but we do want to implement at least some of these things. For example, you get some notifications for a breakpoint, an exception, and a thread being created, things like that. So obviously, you want to do something about it. Well, maybe you want to do something about it. We'll do the very minimum thing we can do in order for these things to work. So let's first focus on the implementation from IronNown. We have to implement IronNown. We have these three functions to implement: query interface, address, and release. Let's go ahead and do that first to make sure that at least we're compliant with the standard COM rules. So let's start with the reference counting. I'm going to create a debugger object locally on the stack or globally, not dynamically. So I'm not going to actually manage any reference count. I'm just going to return something which is not 0. The only thing that we actually do have to work for is query interface. And so the first thing we need to do, of course, is to look at the interface ID. So I'm going to just shorten that a little bit to RIID. And here let's call that PPV to make it slightly easier. So let's see. So we are supporting 3 interfaces here. The first one is IronNown, which we always have to support. And the second one is the one we have here first, because it's going to extend the IronNown and in fact be the first one in the internal vtable. So we can treat both of them, this one and the IronNown pointers, as the same. So debug event callbacks. So let's go ahead and use that. So we have the UID of operator. If this is one of those, then obviously we support it. So we can just go ahead and put here the static cast of iDebug event callback. So IronNown is the same thing of this. We've seen similar implementations, by the way, in previous videos, like when dealing with the Beats service. So feel free to go back there. Maybe there's a more lengthy explanation there in that video. The second thing is the other interface. So we're going to just check for that other interface that happens to be the second one in the list, which is debug output callbacks. And so I'm going to use that, and of course static cast to that. This is important because the return pointer will point to the second vtable. It's not the same value. Otherwise, we technically need to call addref here, but I'm not going to bother with that. Well, let's do that just for completeness, because addref really doesn't do anything here. Otherwise, we have a no interface, which is a standard error code for a query interface. So that should be good enough for the IronNown kind of stuff. So just to verify that we didn't miss anything, let's go back to our main application here. So I'm going to first include the debugger, obviously. We're going to need that. We're also going to need something maybe like printf or something. So let's add that at this point. And let's go ahead and create a debugger. Let's call that dbg. So if we do that and call init, we should find that this should work. Well, at least we hope that that actually works. It won't work, in fact, until we also have a co-initialize call. So let's go ahead and do that. So here's a co-initialize call to initialize com stuff. And then let's go ahead and give it a shot. Let's just make sure that all these initial stuff works as expected. I'm going to change this project to be the startup project, press F5 and hope for the best. Okay, building, running. Here we go to the debugger. Let's go ahead and use init like in one stroke, and notice it returns SOK, and we can see that in fact we do have these pointers being non-null, which means that the creation of the debug client object succeeded, and we have 2 interface pointers to that object. It's all good. Everything works as expected. Okay, good. So we have that, which is something to get started with, but obviously we're missing a lot of things. And one of the things we did in the previous example, in the previous video, we created a process to make it easier to attach to something that we know its ID. So let's go ahead and do that here as well. I'm going to just do some copy pasting here, just to launch an executable of our choosing, just to make it easier for testing purposes. So I'm going to launch this whatever, and then we get its ID. So once we get the ID, we probably want to attach to it. So our next thing here to do might be something like let's have something to launch, like a notepad or whatever. Then we're going to get the PID by calling launch exe, providing the name here. And if this doesn't work, then obviously there's nothing to do. We can just return an error. So it means that executing that exe didn't work out. So when we have a PID, the next thing we want to do, what we did in the previous video, was calling debug attach process, or debug active process. We wanted to attach to that PID. So here we're going to use our debugger object and say attach to process and provide a PID. Seems simple enough, but obviously we have to implement that kind of thing. So let's go ahead and do that and see what that entails. So basically what I'm doing here, I'm creating an API we might want to use. In fact, all the other stuff here, we can even make them private so nobody from the outside can call them directly. There's really no need. This is just internal stuff handled by this debugger object. So let's have here an H result and say something like attached to process, as we've seen. That's what I want to call this function. So here's a process ID we want to attach to a process. And the question, of course, is how do we do that? And so this is where we have to utilize the API that we have. And if we look at the client, one of its functions is attach process. It might not be obvious and we don't see proper completion here, but if we try it now, maybe you can see there's attach something here, like we can even attach to a kernel, which means that we can use kernel debugging with the debugger engine, something that is not available in the standard debugging API, of course. And here's attach process. There are other options. You can see you can create a process by running some executable and attaching to it immediately, but here's attach process. You can see there's a parameter here for a server, and server just means that it's possible to work remotely, attach to a process that is running on a different machine. We're going to just use local stuff here. I'm not going to go into a different machine or anything like that. So it's just going to be a 0. And so we're going to provide 0 here as representing the server, and then the process ID that is something that we have, and then there's an attach flag. There's a bunch of flags we can use, and there's a debug attach set of constants here, and we're going to use the constant called the invasive. Invasive just means that this is like the standard kind of attach that you might have. So I'm going to use invasive here. Let's go ahead and just press F12 to see what we have. You can see there's a bunch of flags here. There's a default, which is in fact invasive as well. This says that don't break immediately. So let's just use the normal attach default. We'll just go with that. And of course we have an H result here. So again, I'm going to wrap that in the HR macro to bail out if something goes wrong. And obviously I've done here something which I didn't really want to do. So let me just fix that. I want to have that in my CPP file, of course. So let's go and do that here, like so. Okay, so we have that. We're attaching to the process. In fact, to make sure that we do have the ability to actually break when we just attach initially, we have to set something called an engine option. So there's a bunch of engine options. I want to add one of those, which might not be the default. So there's again a bunch of constants here. One of them is called initial break. Initial break means that I'd like to break as soon as I attach to a process. And so I want to set that as a default, which I'm not sure it is in fact the default. And like I mentioned, all these things are fully documented. So if I look for something like add engine options, as I've shown here, you can see there's the options. If you click that, you can see all the various options the engine supports. It's all documented in a good enough way for at least most cases. So I'm just taking a shortcut here because I remember some of these things. So I'm just using them here. So once we have these options, then we attach to the process. Is that good enough? I mean, are we done? Is it actually being attached? And the answer is not quite. There's another function you actually have to call, which is actually on control, if I remember correctly, called wait for event. So wait for event, its purpose is kind of saying, okay, now let's just wait for the actual attach to happen, because things happen behind the scenes asynchronously in some manner. And so there's just no really flags to provide here. We're just saying infinite. We're going to wait until this is done, because really there's nothing else that we can do. So we might need to have these calls happen from time to time. In order for me to make it slightly easier, and also we'll have to call that from the outside as well, I'm just going to wrap it. So let's just go ahead and do that, just to wrap it in a way, let's call that wait for event. so we won't have to like do that long call every single time. So I'm just going to put it here and just do a return here for whatever we get here, and then we'll just return wait for event. We'll see that in the main function we'll have to use that as well after executing a command. So I'm just wrapping it here to be able to be used outside, not just internally, and internally we'll need to do that as well. Okay, so we have attached to process. This is good. This is like a good start. Are we done? Can we start testing stuff? Well, unfortunately, not quite. In fact, not even close. So again, if you read the documentation, you'll find that when the debug client is created, it's going to call back to a function called getInterestMask. So it's calling back to us and saying, you know what, just tell me first what kind of events or notifications you care about. And so there's a bunch of events like creating a process, a thread, a DLL being loaded, and exceptions, things like that. And you have to tell the debugger engine or the debugger client here which events you're interested in. You might not be interested in everything. And so there's a debug event, something here, many of those. So I'm interested in breakpoints. I'm interested in, say, a create process. I'm interested probably in create thread. Maybe I'm interested in everything, and that would make sense, at least for many of these notification types. There are other stuff like debug event, load module, and the list is long. So if you just press F12, you can see there's lots of interest stuff here that is happening. So obviously, in a real debugger that is fully featured, you probably want notifications about everything. But in something that we're going to write here, you might not need everything necessarily. And so we might get away with just a subset of these notifications. You might also want an exception here. And so once we set that up, we just return SOK saying, this is the stuff we're interested in. And just to verify, let's go ahead and press F5 here and run this already. Let's see if we actually get the call here. So first we're creating a debugger object, we're doing an init, and at that point nothing has happened just yet. Now we're going to launch the executable, so here's our notepad, and then we get a process ID and we do attach to process. So once we do that, nothing seems to happen at this point, which means the debugger has not yet called our getInterestMask function because nothing has happened just yet. And the reason for that is because we actually didn't register for any kind of event just yet. So we actually are missing some work here to be done. Because we've implemented interfaces, that's of course necessary, but we didn't really set up any actual registrations. We have to register once we get the debugger object properly created. So going back to init here, we have to do something here. So we have to register for something, or to say that we're interested in some information here. And so you can see there's a function called set event callbacks. So basically we're saying to the debug client, when you want to say something, please call this object, because really we are the ones implementing the event interfaces. Same goes with the output callbacks. And we need to provide a pointer to that implementation. That's actually exactly what we're doing. We have that implementation. So now things should be a bit different. We should find that the getInterestMask is at some point being called. So here's init, and now it's already being called. So it's part of our init function here. We can see once we called set event callbacks, the first thing that happens, or one of the things that happens here, we can try to load some symbols if we have any. So you can see there's some set event callbacks here in the debug client implementation inside the debugger engine. It calls us back with getInterestMask, so we can specify what we actually want to support. So we made some progress. We have that mask, so that's good. Maybe we'll need some other details in the mask, but for now we should be fine. And then other events might also come across us. So for example, we talked about the fact that there's a create process notification here somewhere, and so we expect that to actually be provided here. And so maybe this one is going to be called as well. And maybe some others, like here's output. So let's see if output is being called as well. And you can set a breakpoint any one of these things to learn about how the debugger engine works. Here's create thread, here's load module. Let's just put some breakpoints here to see what is actually going on even before we actually execute any commands, just by attaching. So I'm going to press F5 here, and you can see we hit a breakpoint here. So we have a breakpoint in output. You can see the text here provides some details as to what is going on. Here's the text. Here's the initialization, the initial part of the text. We'll probably have more text as things will continue. I'm going to press F5, we'll land here again. So we have multiple text things being provided to us, and you'll recognize some of these things if you've launched WinDebug or one of the other debuggers. It will look very similar. And so what I'm going to stop here for a moment. Obviously we have lots of text here coming in. So let's just do something with that text. And so I'm just going to do the simplest thing possible, simply just displaying that text. Just by using the standard printf function. Let's just add stdio to make sure we have that support. I'm just doing a little printf, nothing fancy there. So here's our output window. We'll see what happens when we try this again. So I'm debugging, running this again with the debugger, like debugging the debugger in this case, kind of silly perhaps. So we landed create process as we expect, but even before that, we get some output. So you can see there's some output here, there's some DLLs seem to be missing, and that's because we're missing the DLLs that typically are providing with extensions for many of the commands you might be familiar with the debuggers. And they're not provided apparently by the NuGet package, so we actually have to copy them from debugging tools for Windows installation, which we'll have to do. But obviously you can see here we have a symbol search path, which is coming from the anti-symbol path environment variable that you may be familiar with, or whatever is configured at this point. And you can see there's a module being loaded, which is notepad.exe. And now we get a callback here saying a new process has been created from a debugger's perspective. And we get some details about the process, like the image file handle, some other handle to the process, the base offset, lots of stuff we can use, like the image name itself and the module name. So you might recall in the previous video we had to work hard to get some of this information. Here we get that sort of on a silver platter, ready to go. And so obviously I might want to do some printf work here or some other stuff. Let's press F5 and continue a little bit, and then we'll land in another load module call, which this time corresponds to some DLL probably. So here's the module name, it's anti-DLL, which again not very surprising. Here's the image name and the full image name, see Windows anti-DLL and all that. And again, we don't have to work hard to get information. Probably I want to display that as well. So we're going to press F5, we'll get to the same breakpoint again, because we have another module name. This time is kernel32, and we have the image name. So all these things we get from the debugger engine. Let's just remove the breakpoint because it's pretty noisy. We have lots of DLLs loading. And now we have a thread being created. That's the first thread in the process. We also get information about that, like the offset and other stuff like the data offset, which is actually the TB of that thread. And we can probably move to hexadecimal to make this a bit easier to see, but maybe that's not easy regardless of how we look at that, hex or not. And so on. So I'm going to continue, and we have threads being created, and at the end of the day, this is what we get in the output. So you can see there's some stuff that fails here because we got notifications and we actually returned e-not-impl, which is not a good thing to return. So we want to return SOK, so we're good with all these notifications. We don't want to return something which is bad, even if we're like not doing anything interesting here. So obviously we can display information about things being loaded or unloaded, all that stuff. So I'm going to just replace the e-not-impl with SOK, at least some of them, probably the most important ones. Here's create process SOK. So you can see that events start flowing, which is a good sign, which means that things are kind of working. And let me just also have a breakpoint here, and I'll explain what we actually have to return here, which is not completely obvious. So here's create thread. So I think we're good to go for now. Let's look at what should we do next. So next thing, let's see if we get into breakpoint here. Remember that we asked to stop at initial breakpoint. So maybe we can do that. Maybe we'll see if we actually break here. So I'm going to run it again. Again, just press F5. We get to the create process call. Again, not surprising, obviously. We get the output now in the initial output here. And then press F5 to continue running. And we're basically done. So we got some output as similar to what we get when you attach to a process. So here's a notepad. If I open my standard WinDebug, so here's a WinDebug, and I do attach to process and look for that notepad thingy, then we'll see that the initial output is kind of similar. So we have a bunch of DLLs that are loaded into the process address space. It looks kind of similar. We have more DLLs here because it took some time for me to attach to the process, whereas here we're attaching to the process almost immediately, so we see less DLLs loaded at that point in time. We just see a small number of DLLs that loaded at the point we actually attached. We can do a little experiment here to change that. Let me just remove this notepad out of sight. Let's just remove that. And here, before actually doing the, let's go to our main application here. Before actually attaching to the process, let's do a little sleep. Let's just sleep for 2 seconds just to show you what that would look like. Let's run this, and we should see more DLLs loading up. So we're waiting 2 seconds, and then you can see the list of DLLs is much longer because Notepad had more time to continue its initialization. Only then we had a breakpoint here. So notice we had a breakpoint here. And in fact, a breakpoint is, it might seem like weird, why didn't we stop here at breakpoint? And the reason is that it's not really a breakpoint in the sense that we didn't set up that breakpoint officially. It's actually an exception. So it's actually, a breakpoint is in fact a kind of exception. This is about a breakpoint that we actually set, which we haven't done yet. So let's try this again, just one more time to see what that looks like. Maybe we will hit that breakpoint, so to speak, in the exception once we attach. Okay, so apparently nothing is happening here. It's very weird. Where are we? Let's see. We're probably stuck somewhere. Let's see where we are stuck. Okay, let's look at what is going on. We're stuck at output for some reason. So we have some output here. So why is that a problem? Okay, so we have some output. We don't, I think yeah, my bad. I pressed enter in the console. That's my bad. And so you can see, we see the output here. When I pressed, I clicked in the console, it froze everything. That's a console feature. And then we can see all the DLLs, but then we reach the initial breakpoint, and you can see that it's actually an exception. And the exception code is actually, it's really a breakpoint exception. So if you look at the exception value itself, let's look at hexadecimal stuff, something that you might recognize. The exception code is 800000003. That's the exception code for a breakpoint. You can see it's in this case, it's the first chance of that breakpoint. So I returned in not impl, which is the wrong thing to do. I actually have to say what is my intention to do with that breakpoint. Should I actually break or do something else? It really depends on what I want to do. It depends on how the debugger is supposed to behave, so to speak. But we have to do something about it. We have to look at the exception code, and based off of that, we need to decide what to do next. And so the way to do that is to look at the exception code, and based on the exception code, return one of two possible, well, I would say two values which make sense, which is whether to actually break or to continue like nothing has happened. So we need to return one of those values based on whether we want to actually break. So if you want to break, let's call that breakpoint, because I'm going to set that as a member so we know that we are in a breakpoint. And if it's a breakpoint, we want to break, otherwise we want to continue normally. And if it's a different exception, let the application figure it out, especially if it's a first chance. But of course we can change that behavior just like we get the option to do in tools like WinDebug, in the event properties that you might be familiar with. So here I'm going to say breakpoint hit is going to be equal to true if the exception, we have the exception code here, is the exception code for a breakpoint. So that's something like this, if I have enough values here. So if this is this one, and there's another one which is similar, so I'm going to use that as well. And this one is about like a single step kind of breakpoint. So if it's one of those, I want to say this breakpoint should be true, otherwise it should be false. And I want to return, in the case of true, I want to return break, telling the debugger, please remain in the break status, don't continue execution, don't let the target process continue execution. So obviously it's a member we need to add, so let's add that. Let's call that breakpoint, just breakpoint, good enough. So it will start with the value of false and we will change that as needed. Why do we care about that? We care because when we are in a breakpoint, we'd like to have the user, the human user, to be able to issue commands. And so you might expose this information outside of this debugger object by having a function here is in breakpoint. We want to return true if breakpoint is true. So this is going to be important later. So I'm going to just return breakpoint here as the Boolean value. So you can see the basic idea is some kind of interaction between the debugger and our implementation here, the debugger client and our implementation, which is in the debugger class. Maybe it's not a good name, but we'll use that because it makes sense. We wrap here these debugger client interfaces. So now we need to move on. We want to continue doing stuff. So obviously we have these various events which you can respond to, of course, and a typical debugger will add information to its internal database about threads being created and exited and processes and so on, DLLs. The thing that we can do is just to display some information here just to prove that things work as we expect. So for example, in the case of a module, let's just write something like module loaded and display its name. In this case, module name, or I want actually the full path here just for fun, so image name. And we can also add the address just to prove a point. So our address here is we have the base offset, which I think that's what we need, and we also have the module size and stuff like that. So let's go with base offset. This is the address it is loaded into. So again, just to prove a point, let's run this thing without actually. Okay, so this is base offset. It's actually a unsigned long 64. So technically, I have to do something else here, like LLX or something similar, but it doesn't matter. I can just cast that to p void. So let's go ahead and do that, and with 2 seconds, and you can see we have the output coming from the debugger itself, but we also have that's the mod load thing, but we also have our own output here, which is module loaded. And so I can of course decide not to display this thing coming from the debugger, but I want to display everything, and this is just some extra just to prove that we have control over things and we know when things happen, when we get these events. Okay, so now we need to continue, but as this video becomes pretty long, we'll have another one to continue the implementation to have a full but still a simple debugger. See you in the next video.